Day 13 of 365, and today we're killing a bad habit. You've got an array with exactly 3 kinds of values, 0s, 1s, and 2s, and you need it sorted. Your instinct? Arrays.sort. It works. It's also leaving performance on the table. By the end of these 5 minutes, you'll sort this array in a single pass, with 0 extra memory, using a technique called the Dutch national flag. And you'll recognize it in interview questions for the rest of your career. First, let's respect the naive approach, because it's not wrong. You walk the array once and count. How many 0s, how many 1s, how many 2s? Then you walk it again and overwrite. 0s first, then 1s, then 2s. 2 passes, done. It's O(n) time, and it's perfectly correct. But notice what it costs. You read the entire array twice, and for objects instead of plain integers, that counting trick falls apart. We can do better with 1 pass. Here's the mental model. Picture the Dutch flag, 3 horizontal stripes. We want our array to end up the same way. All 0s, then all 1s, then all 2s. We use 3 pointers. Low marks the boundary where 0s end. High marks where the 2s begin. And mid is our scanner, walking through the unknown middle. The invariant is everything left of low is a confirmed 0, everything right of high is a confirmed 2, and everything between mid and high is still unexplored. Hold those 3 truths at once, and the algorithm writes itself. Let's code it in Python. Low equals 0, mid equals 0, high equals length minus 1. Then, while mid is less than or equal to high, if nums at mid equals 0, swap it with nums at low, then increment both low and mid. If nums at mid equals 1, it's already home, just increment mid. And if nums at mid equals 2, swap it with nums at high, then decrement high, but do not move mid. That last line is the whole interview. Why does mid stay put? Because when you swap a 2 to the back, the value that comes forward from high is unexamined. You've never looked at it. It could be a 0 that still needs to travel left. So you reinspect that same mid position next loop. But when you swap a 0 forward, it came from low, which sits at or behind mid. You've already cleared that region to 1s, so it's safe to advance both. That asymmetry is exactly the pointer crossing bug people hit. They advance mid after a 2 swap, skip an element, and the sort silently breaks. Let's trace it on 9 elements. 2, 0, 2, 1, 1, 0, 1, 2, 0. Mid hits a 2, swap with high, high shrinks, mid stays. Next it's a 0, swap with low, both advance. A 1, just step mid forward. Each value gets placed in one comparison, mid and high march toward each other. And the moment mid passes high, every element is in its stripe. 1 pass. No counting array. No second red. This is leak code 75, sort colors, but the pattern is bigger than colors. It's the partition step in 3-way quicksort, Dijkstra's variant, which is why competitive programmers reach for it on duplicate-heavy input like 2, 2, 2, 2, 1, where naive Lemuto partitioning degrades toward O(n squared). In Java, you partition task objects by enum ordinal, low, medium, high, in place. In JavaScript, you bucket notifications by info, warning, error before rendering. Same 3 pointers, any 3-valued domain. So here's the category to file away. Any in-place bucketing problem with a fixed, small set of values. When the value range is bounded, you don't need a general comparison sort. You need invariants. Day 13 done. The takeaway: most sorting problems aren't sorting problems. Exploit structure in a linear pass beats a sort every time. Subscribe for day 14.